Good morning, middle school students of Great Lakes Academy. It is Mr. Manta. It is, Monday, April 27th, and we got another video lesson for you. We're moving right along today and getting deeper and deeper into this whole idea of chemistry and starting to talk about chemical changes today. We're going to see some really cool little video clips and images of cool chemical reactions going on. But first, what I want to do, since we've been in this chemistry unit for a while now, is run through a recap of everything that we've talked about so far. I'm going to go through all 8 lessons that we've had in this unit so far and kind of recapture the main ideas. So, in lesson 1, we learned this very basic idea that anything that has weight and takes up space is matter. So anything around you that you can touch, all this everyday stuff like your ham sandwich or your pencil or your desk or the air that you're breathing is matter because it has weight and it takes up space. The only kinds of things that aren't matter are things like dreams or light or energy that don't have weight or don't take up space. Second of all, in lesson 2, we learned that if you could zoom in super, super close, you would see that all matter is really made up of tiny, tiny particles. Everything is made up of tiny, tiny particles of itself. So, for example, you might have a sandcastle there on the beach, and if you could zoom in super, super close with a microscope, you would see that the sandcastle is made up of little grains of sand like this. But even those grains of sand are made up of tiny, tiny particles that are smaller than that. And this is a picture taken with an electron microscope. That's a super powerful kind of microscope of all these tiny little particles that make up something like a grain of sand. They're way, way, way too small for you to ever see with your eye, but they make up everything that's around us. In lesson 3, we also learned, actually, I'll add in lesson 2, that particles behave differently in solids versus liquids versus gases. And that's what makes each of those states of matter different. So we've seen this animation a few times now. We know that in a gas, the particles are bouncing around all over the place to fill up however much space they have. In a liquid, they're kind of flowing freely around each other. And in a solid, they're holding rigidly to one another so that a solid object holds its shape. Moving on to lesson 3, we talked about how all matter has properties. We've been talking about properties a lot since then, that you can observe or you can measure. And we saw our first kind of big list of common types of properties that we're all familiar with. Things like color, material, shape, texture, temperature, length, width, height, volume, and weight as well. That was kind of our introduction to this idea of properties. And we also knew that that wasn't all of the properties. In lesson 4, we talked about how we can use those properties to identify mystery objects, to figure out what mystery objects are. And that's why we talk about properties so much in chemistry, to figure out what it is that we're looking at when we have some mysterious chemical or object. The example that we used was our friend Pluto, the dwarf planet. And we said, well, scientists were trying to figure out whether Pluto was a planet or a dwarf planet. And so they looked at all the properties of planets, and they looked at all the properties of dwarf planets, and found that Pluto matched up better with the dwarf planets because it met all of the right properties than it did with the regular planets, where it didn't match the properties because it wasn't at least 3,000 miles across, it didn't have other objects in their orbit. So we confirmed on that day that Pluto is in fact a dwarf planet based on its properties. That's why we use properties, that's why we talk about them, to identify mysterious objects. In our 5th lesson, we learned that different kinds of matter have different melting points and boiling points. We looked at a whole bunch of thermometers that looked kind of like this, and we learned that a melting point and a boiling point are the temperatures at which matter changes between solid, liquid, and gas. So we learned that the melting point of water is down here, right at 0 degrees Celsius, and that any temperature, anytime you have water that's colder than that, it's going to be solid at those temperatures. We learned that the boiling point of water is up here at 100 degrees Celsius. So anytime you have water that's between 0 and 100 in this range, if it's 50 degrees or 20 degrees or 80 degrees Celsius, it's going to be a liquid. And then once you go past that boiling point, anytime you go past 100 degrees Celsius, water is going to be a gas. And all different substances have these different melting points and boiling points where they change between liquid, solid, and gas. We also learned in lesson 5 that different kinds of matter have these other properties that we call reflectivity and transparency. We learned that reflectivity is a measure of how shiny something is, and so this car over here is very reflective, whereas this car over here is not very reflective. And we learned that transparency is a measure of how well you can see through something or light passes through something. And so these very clean windows over here are very transparent, whereas this very dirty window that you can't see through, light can't pass through it, so it isn't transparent. Moving on past that, in lesson 6 we talked about some more properties, specifically chemical properties, and the 4 properties that we highlighted were hardness, malleability, conductivity, and magnetism. Mr. Manta came on the video to do a demonstration of each of these 4 properties, but we also listened to the crash course video, and they gave examples of each of these 4 properties. They said an apple has more hardness than a sandwich, which makes sense. That a potato chip is a lot less malleable than a fruit roll-up, meaning that you can take a fruit roll-up, you can bend it around and squish it and change it into different shapes. We learned that metal is more conductive than plastic. That means that it can, like electricity and heat can travel through metal better than they can travel through plastic. And we learned that this metal water bottle is magnetic, whereas the brown paper bag is not. That means that they are attracted to magnets, and magnets stick to them. Still moving forward, in lesson 7, we learned that most of the time when you combine 2 different substances, you create a mixture. Some examples that we saw of mixtures were things like this value pack, this variety pack of candies, where it's mixtures of Snickers and Twix bars and Milky Ways, all these different things mixed together. Or in the Crash Course videos, they talked about fruit salad, a whole bunch of different kinds of fruits that are all mixed together. If you wanted to, you could separate a mixture back out and create separate piles of blackberries and strawberries and kiwi, because it's only a mixture, so you can separate them back out. And we learned in lesson 8, where we used that lab, that online simulation that you had to go through, about solutions. We learned that a solution is a special kind of mixture where the particles of the 2 substances are evenly distributed. So the particles are perfectly spread out all throughout one another. They're mixed together perfectly. And we learned some vocabulary words that have to do with solutions. For example, a solute is the thing that's being dissolved, like salt or Kool-Aid powder. Solvent is the substance that you're dissolving it in, usually water. Dissolving, we learned what that means when you create a solution. We learned what it means for a solution to be saturated. That means you can't dissolve any more of something inside of it. And we learned that different substances have different solubility. That means that some substances you can dissolve more of in water or something like that, and some of them you can't dissolve very much of. And we looked at simulation and some different videos of solutions, like this one right here, and we learned that we all kind of create solutions sometimes. For example, if you ever take a Kool-Aid drink powder or some lemonade powder, and you mix it into water and you stir it around, you create a solution. These things up here are your solutes, whereas the water is a solvent. When you mix the 2 of them together, you create a solution. We learned all about those different solution terms. Now for class for question 1, what I want you guys to do, all of these words that I've listed right here are all of the words that I highlighted in those past few slides, because they've been kind of the key ideas, the key concepts from our lessons so far. For class for question 1, I want you to go in and tell me, which of these concepts are you still a little confused about? Out of everything that you see here, make sure you look through all of these words and pick out any of the ones that you feel not so sure of. I ask, please don't say none of them, and please also don't say all of them, because those aren't very helpful to me. I'm trying to get a sense of what are like the major ideas that are still kind of difficult for people, so we can spend a little bit more time reviewing the ones that you're confused about. So you can name just one of these things, or you can name 10 of them, but don't say none of them and don't say all of them. If you think you're pretty clear on all of these, pick at least one that you think is a little bit more confusing than the others. We're like, I'm not totally sure I understand, I don't know, conductivity or something, or transparency, and then just pick that one. List whichever concepts you are still a little bit confused about. Pause the video and do that now. I'm assuming that we have now completed that. We are unpausing the video and moving right on. You might be wondering, why is Mr. Manta recapping all this material and having us go through all these concepts we talked about? Well, ladies and gentlemen, we have a quiz on Wednesday. That is why. It's going to be the first quiz in this chemistry unit. It's going to be probably mostly multiple choice, like our quizzes online have been so far. And if you understand all these terms right here, then you're going to do just fine on this quiz on Wednesday. We're going to have some new material today. We're going to spend tomorrow reviewing based on what you guys tell me you're still confused about, and then that quiz will be on Wednesday. All right, moving on from there, we actually have today's lesson, our new material, where we're talking about chemical changes. Now, we already know from lesson 7 that most of the time, when you combine 2 different substances, you create a mixture. And of course, we've talked about different mixtures, like solutions. But sometimes something else happens. Sometimes you create what is called a chemical change. And this is the fun part of chemistry. This is what I think you guys have been waiting to get to, because chemical changes do some crazy things. This is just one example of a video of a chemical change. Look at this. They combine these different chemicals, they light it on fire, and then, oh my god, this crazy, strange, ashen creation rises out of all this stuff that they mix together. I'll let you watch it one more time. This is an example of a chemical change. Wow, it's so cool. I could watch that a million different times. Today, we're going to be talking all about these chemical changes. This is just one example. Chemical changes do all kinds of different stuff. But today, we're going to be learning about what that actually means and how we know that a chemical change has occurred. Before we jump into our crash course video, which yes, we'll have one today, I have a second classwork question for you. So go ahead and pause the video and answer this question. Have you or your parents baked anything recently? What did you make and how did it turn out? We're talking about baking because we're going to learn that baking is one place where we often see in our everyday lives chemical changes happening. And I've actually been baking a lot of things at home. My mom's been baking a lot of stuff. So I want to ask you guys if any of you have baked anything recently. Go ahead and pause the video and answer classwork question 2 now. And I'm assuming now we are unpausing, moving right along, and I will get to read who has and who hasn't been baking things a lot lately. All right, today's big question, like we've said, what is a chemical change? And to help answer that question, we are going to go to our friends over at Crash Course. Let's pull up the video right here. Oh, I didn't restart it. Full screen it. And hear from our friend, Sabrina.
You know what's a really great way to learn about science? Baking. After all, baking is pretty much just chemistry, and chemistry is the science of different kinds of matter and how that matter can change. Sure, some of the equipment used in baking and in chemistry isn't quite the same, but both baking and chemistry require careful timing and measuring, and both of them result in the formation of a mixture. For example, you can change matter like eggs, milk, flour, and sugar into a tasty dessert. Now, you already know that a mixture is anything made by combining two or more different things. And some kinds of mixtures, like the fruit salad we had at our picnic, can be separated back into the substances that made them. But that's not true about all mixtures. Sometimes mixing things together makes a whole new substance. We call this a chemical change. But what is a chemical change? A chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Unlike the mixtures from our picnic, chemical changes usually can't be undone. Let's observe an example of a chemical change. Observe, people. We're not trying this at home. When we observe a lit match, we see that the match burns. As it burns, it changes into burned wood and ash. We can't change this ash back into a match, so burning is an example of a chemical change that can't be undone. But wait, there's more. Chemical changes often make matter change color, like the blackened remains of the match. Sometimes chemical changes make smells, or release light or gases, and lots of chemical changes require either the giving off or taking in of heat. A burning match gives off light, smoke, and heat. All of these things are evidence that when we look at a burning match, we're looking at a chemical change. Now we can do a simple investigation to show how some chemical changes can yield a seriously yummy result. When we mix the ingredients of a cake, we're mixing together different kinds of matter. Say you have flour, sugar, milk, and eggs. When you put them in a bowl and stir, you're mixing several different substances together to make cake batter. And when you pop this mixture into the oven, after a short time, you have a new substance: cake. Now, before you eat it, let's check this science cake for evidence of a chemical change. Did the reaction give off or take heat? Definitely. The cake batter needed the heat from the oven to change into cake. If we left the batter on the counter, it would stay batter. Is there a color change? Check. The batter in the pan was yellow, and now it's a nice golden brown. Is there any smell? Well, if you've never been in a bakery or some grandma's kitchen or just never smelled a cake baking, then I feel bad for you, because it smells amazing. Were any gases released? Let's look at our cake before and after. Before, we have a wet, gooey batter. After, we have a nice, fluffy cake. As the cake was in the oven, some of its ingredients released carbon dioxide gas. We can see evidence of carbon dioxide when we cut the finished product. All those little holes in the spongy-looking cake are caused by this gas. Our last piece of evidence that we've witnessed a chemical change? This change can't be undone. For example, we can't get the water we put into the batter back out of this cake, even if we were to squeeze it really really hard. We'd get crumbs, so let's not try. So, a chemical change is a change that occurs when the particles that make up two or more substances are rearranged to form a new substance. Most of the time, chemical changes can't be undone, and we can tell they're occurring by observing them and noting things like changes in color, release of smell or light, and whether they take in or give off heat. All in all, I'd say that sniffing out chemical changes can be a piece of cake.
Makes me think Mr. Mentor should be ending with corny jokes on each of my lessons. Alright, as usual, they went pretty fast, so we're going to recap those main points on our own time. Now, what is a chemical change, right? That's the main idea that we're talking about today. Here's our key point. Yes, you should write it down in your science notebook. A chemical change is when the particles that make up two or more substances are rearranged to make a new substance. And the new substance, the reason why I've bolded it and circled it, and now I'm underlining it, is because that's really the important part of this, that chemical changes make new substances. This is different from a mixture, where you just have your old substances mixed together. So if you create a new substance, that's a chemical change. But if you just take your, a bunch of stuffs you have, like flour and eggs and milk, and mix them together into a batter, you haven't actually created anything new. You've just mixed those things together, and it isn't a chemical change. I try to make this as absolutely clear as I can. Now, chemical changes, like she said, happen all the time in baking. If you were to bake a cake, there's two basic steps that you would have to take. First of all, you could start with all of your ingredients, and we see here flour, eggs, sugar, butter, milk, the ingredients that we use, all different kinds of matter, and we mix them together and create a mixture. You'd usually call this kind of a mixture a batter or a cake batter, right? All you did was you take all the matter here and you combine it, so it's now mixed together. I want to be very clear, this is not an example of a chemical change yet, because we haven't created anything new. If you can zoom in super close on your cake batter mixture, you would see that it's just a mixture of particles of flour and eggs and milk and everything else. Nothing new has been created yet. You've just mixed a bunch of stuff together. Then you take that batter, the mixture that you've created, and you put it in the oven. And you bake it for, 30 minutes or an hour. And then you have a baked cake. Then, in that point, this transition right here from batter into cake is a chemical change. In this case, we've created a new substance. Over here, we just had a bunch of old substances mixed together. Now we actually have something new, cake, that is a totally new substance, which means that we've created a chemical change. Chemistry is really the science of creating new stuff out of old stuff, taking a bunch of old eggs and milk and flour and making something new, like a cake, out of them. It's a chemical change. But you might be asking, okay, so that's one example of a chemical change, but how can we know if a chemical change has occurred? Like Mr. Manta is telling me right now that baking a cake is a chemical change, but do I just have to trust Mr. Manta to tell me all the types of chemical changes that are out there, and then I'll have to just remember a big list of, baking is a chemical change, but mixing isn't? No. What we can do is, key point number 2, figure out the signs of a chemical change. Again, since this is a key point, you should definitely be writing this down in your notebook. We're going to go through each of these 6 signs of the chemical change, but we have all 6 of them listed right here, so write them down. Number 1, if your change that's occurred can't be undone, then it's probably a chemical change. Number 2 is that you can look for changes in properties, such as color or texture, and if something has changed its color or changed its texture, you've probably had a chemical change. Number 3, if it makes smells, then you're likely to have had a chemical change, like baking a cake or burning a match. Number 4, if it releases light, like burning a match, right, creates light that you can use to light up a room, then that's probably a chemical change. Number 5, if it releases gases, like baking a cake, it smells so good, there's little bubbles that can form, we'll see some other examples, then that's probably a chemical change. And number 6, if it gives off or takes in heat for a change to occur, then it's probably a chemical change. Any 6 of these things can be a sign of a chemical change. You don't need all 6 of them to know that you've had a chemical change for sure. The more of them you have, the more likely it is that whatever change you're looking at is a chemical change. So let's go through each of them one at a time. Number 1 is that it can't be undone. The example that they talked about in the video was taking a match and burning it. After you burn the match, you now have a burnt match. You can go from this picture over here to this one by burning the match, but you cannot go back the other way. You can't take a burnt match and unburn it. There's no such thing. Once you've burned the match, that change can't be undone. So burning the match is a chemical change. A second way that you can know is by looking for changes in properties. Oh goodness, here, I have to fix this slide. I have to fix the slide on the fly. Just wait, just don't pay attention to that for a second. All right, here we go. The second way that you can know is if there are changes in properties. So we're going to look at our baking a cake example. Over here we have our cake batter that's just a mixture, and some of the properties that it has is that it's very light in color. It's like a little bit yellow, but it's almost white. It's liquid at room temperature, and it's very malleable. Since we learned what that means, we know that malleable means you could kind of squish it and stretch it and move it around without breaking it. After we've baked the cake, those properties have all changed. Now we can see that our cake is a darker color. It's more dark tan or almost orange over here, whereas it was a lighter color before. It's solid at room temperature now, and it's not malleable anymore. If you try to like bend and stretch that, you can kind of do it a little bit, but if you try to do it too much, it'll just kind of crumble apart and break. It's not malleable anymore. It's changed its properties. We have these properties over here and these properties afterwards, so we know that it was a chemical change. This is a cool GIF, and this is what I had to fix just now. A cool little animation of a really interesting chemical change happening. So these scientists, they mix all this stuff together, and all these liquids just look like clear liquids, like almost like they're water. But they aren't, they're special chemicals. And after they mix them together, you can see that they start changing their colors in these really bizarre ways. That's how we know that what they are showing here in this little video is a chemical change. Watch it one more time. They're clear at first, and then suddenly they change red, and then suddenly they change to this like dark brown, almost black color. We have a chemical change going on here because the property of color is changing. Another way we can know we have a chemical change is if it makes smells. Now, the examples that they talked about in the video are very good examples for this. If you ever take a match and you burn it, and you stand near it, you will probably notice that it creates a smell. There's a specific smell of something burning that is an indication that you have a chemical change at hand. It's a bad smell, unfortunately. On the other hand, if you take a cake and you bake it and you open up the oven and you give that a whiff, it's a very nice smell. Doesn't matter if it's a bad smell or a good smell. If something makes any kind of smell, it's probably a chemical change going on. Another way that we can know is whether something releases light. Things that release light are often chemical changes. The obvious example again is burning a match. This is a cool, just like slow motion video of a matchstick being burnt and giving off all this fire. That fire is kind of lighting up the area around it. It's lighting up. It's very bright. It's creating new light. That means it's a chemical change. One of the really cool demonstrations that chemistry teachers do sometimes that I would love to do in person, but I don't think we can do that, is you guys may or may not know that if you burn different substances, the fire that you can create sometimes is different colors. And so most fire you see is this kind of orange color here, but if you burn things like lithium, or I think that's strontium, that's sodium, this one's copper, I think, and that's potassium, you can create fire that's different colors. You can have green fire, or more red fire, or kind of yellow fire, all different colors. These are all releasing different colors, different wavelengths, as we learned, of light. So in all of these little petri dishes here, you have chemical changes going on because they're releasing light. Number 5 is if your chemical change is going to release gases. So again, looking at the burnt match, anytime you burn a match, you create a whole bunch of smoke. The smoke coming off of that fire is an example of a gas that's being created from the chemical change, and that tells you that you have a chemical change happening. Another example that they use in the video, and this one's a little more difficult to explain, if you ever bake a cake and then you look really closely, once you cut into the cake, you'll notice that there's lots of these kind of tiny little pockets or holes inside of it. And where those come from is that while the cake was baking, it was giving off a certain kind of gas that was creating these pockets of air inside of the cake. So you can't see it directly happening, but you can know from looking at these little holes that gas was being released when you baked a cake. That means that was a chemical change. My favorite example of this is if maybe your parents sometimes take, there's a small pill called Alka-Seltzer that people take sometimes if their stomach is bothering them. And when you take Alka-Seltzer, you just put it in a glass of water, and it starts fizzing all crazy and creating all of these bubbles. All of that air, that gas coming out of it is a gas, and it tells you that when you put Alka-Seltzer in water, you have a chemical change going on. Our sixth and our final sign of a chemical change is if something gives off or takes in heat. Now again, with burning fire, this is an obvious example. It's anytime that you burn firewood. The wood on its own isn't very hot, but then once you light it on fire, it starts releasing heat. And people can sit around a campfire and warm their hands to take in that heat, or you can sometimes you can cook your food with it and take in that heat. This is an example of something giving off heat, and therefore it's a chemical change. The other one that they talked about in the video is that when you bake a cake, well, you have to put it into an oven where it's like 400 degrees, and the cake takes in all of that heat in order to turn from cake batter into an actual cake. It takes in heat, and that is another indication that it is an example of a chemical change. All six of those things are signs that a chemical change has happened. For classwork question 3, I want you to go ahead in the classwork questions and name at least 3 signs that a chemical change has happened. We just talked about 6 of them, so you should at least be able to give me 3. Pause the video and answer classwork question 3 now. I'm assuming that we are now on pause, and we're going to move forward, and I look forward to seeing your answers. Alright, folks, we are moving on to our independent practice for today. We've learned about what a chemical change is and 6 different signs that a chemical change has occurred. Go ahead and number your notebooks numbers 1 through 8, and your 8 independent practice questions are here. Pause the video and answer all 8 of these in your notebook now. Alright, moving forward, I'm now assuming that we have unpaused and you are waiting for the answers because you have given your best answer to each of these 8 questions, and here they are. Number 1. Most of the time when you combine 2 substances, you just create a mixture. So one thing to keep in mind about chemical changes is that they're more rare than just normal mixtures. Most of the time when you put 2 things together, you just create a mixture. Chemical changes are more special. Number 2, a chemical change is when the particles that make up 2 or more substances are rearranged to make a new substance. It's not a chemical change unless you really created something new that you didn't have before you combined the things. Number 3, one sign of a chemical change is that it can't be undone. You can't, after you bake a cake, you can't go into it and take the particles apart and separate back out your flour and sugar and eggs. They've now been baked into a cake, and that thing is set, and you cannot undo it. Number 4, true or false, chemical changes often make smells. That is true. Smells are a common sign of a chemical change. Number 5, another sign of a chemical change is that an object changes some of its properties, such as color or texture. Number 6, true or false, burning wood gives off light and heat, so it's an example of a chemical change. That is true. Both of those things are signs that a chemical change is happening. Number 7, true or false, when you mix together the ingredients for a cake, you're making a chemical change. That is false. When you just mix together the ingredients, you're just creating a mixture. You haven't created a chemical change yet. And number 8, true or false, when you bake a cake, you're making a chemical change. That is true. As we've seen, there's a whole bunch of signs when you bake a cake of things happening that tell you have a chemical change going on. As always, go ahead, star the questions that you got correct in your notebook and fix the answers that you got wrong. And then in today's classwork form, check off all of those questions that you got correct. Alright, ladies and gents, that is all that we got today. It is our exit ticket time. You have no independent reading. Go ahead and knock out your classwork questions and your exit tickets. And of course, I want to mention today's cool thing. If you enjoyed those little videos that I was showing today of examples of chemical changes happening, there were a lot more that I didn't have time to include in today's video lesson, but you can go find them online yourself. So this is an article from Science ABC, I'll try to link, of 10 fascinating chemical reactions that will blow your mind. And this one, you can see that this scientist has put a giant gummy bear into some kind of chemical, and it explodes and destroys the poor gummy bear. That was just one of these really fun 10 different chemical changes that they're showing. Alright, go ahead and knock out your exit ticket. That is all that we got for today. Tomorrow we're going to review, and then on Wednesday we're going to have our quiz. Take care, folks. I'll talk to you tomorrow.